Hello guys, welcome to the channel. Today we will discuss support vector machine algorithm for classification. So what is support vector machine? Support vector machine is a supervised machine learning algorithm used for classification and sometimes regression also. Okay? Its main goal is to find the best boundary, or we can say hyperplane that separates different classes. For example, spam versus not spam, cat versus dog, fraud versus normal transaction. It basically finds best boundary called hyperplane that separates different classes, like it separates spam not spam by hyperplane, cat versus dog, fraud versus normal transaction. It basically separates these two classes using hyperplane. Okay, for example, real life example. Re- we will have some red balls on one side, blue balls on another side. Okay, then there can be many lines separating them, right? So SVM chooses the line that leaves the maximum distance or margin from both classes. Means the basically distance between these classes and hyperplane must be maximum. Then it will choose that hyperplane. Okay, basically larger margin is equal to better generalization, lower chance of wrong prediction, right? Because, see, suppose this is a graph where I have this hyperplane, and these are my two different classes, right? So if there will be highest, means there will be more distance between these two classes by this hyperplane, then it means my classes are classified perfectly, because the distance is far from the hyperplane for both classes. Okay, so it means by the hyperplane, it basically classified the data perfectly, right? So, so this is how SVM works. It creates a hyperplane, separates the classes, and predicts the output, right? So this is how vector machine for classification works. Now, some important terms in SVM. Hyperplane. Hyperplane, a boundary that separates classes, which I have already explained. In 2D plane, it is called line. In 3D plane, it is called in 3D it is called plane. High dimension is hyperplane. Margin, distance between hyperplane and nearest data points, means these are my data points and this is my hyperplane. So margin between the data points and hyperplane, basically distance from the data points to the hyperplane, right? That is called margin. Support vectors, the nearest points to the hyperplane. These points are very important because they decide the position of the boundary, means hyperplane. Without support vectors, hyperplane changes. Okay, so suppose this data point is much closer to hyperplane, then it is support vector. This point is much closer to my hyperplane, so this is support vector, right? So this matters more now. Now, what is kernel? Basically, kernel is something which converts low dimensional data into higher dimensional data. Sorry, space. Okay. So the separation between two different data points, between two different classes, separation of between two different classes, or we can say categories, becomes easier by kernel. Okay. So first, kernel is a linear kernel used for linear data, polynomial for which creates like curved creatures, which is not linear, and RBF for complex non-linear data. non-linear data plus complex. Okay. Sigmoid looks similar to neural networks. When I will cover deep learning neural networks, then I will cover this also. Okay. So now we will check how we can perform SVM for classification. Okay. And how we can use kernels also for linear data, linear, polynomial. Like if I have some not linear data, means I have some curved features in our between our dependent variable and independent variable, then I will use polynomial kernel RBF when I will have complex or non-linear data, right? So this is the different cases of kernels. Okay. Now this is my data set on which I will perform my SVM classification. Okay. So how we can perform it? First, we will import some required libraries. Import pandas as PD. Import matplotlib dot pyplot as plt. Import cbol as SNS. Okay. Now I will load my dataset slash CSV. So this is my data. I will right click, copy path. I will paste it here. I will check my first three rows by checking uh, dot head. So yeah, my data gets loaded and these are my first three rows. Now suppose I will plot a graph to show how my data is looking like. Suppose I will first give some figure size. SNS dot scatter plot. X is equal to, I will take CGPA. I will take Y as academic performance and U is equal to my placement, right? Placement. Okay. Now I will write plt dot show. Oh, sorry. I have not given data as data is equal to. I have loaded my data into data variable. So I'll give that also. So yeah. So this is how my data is looking like. A little bit very complex data, right? Okay. So now I will first divide my data into input and output. I log. I will take my all input columns into my X means give this means give me all rows, give me all columns, but don't minus one means but don't give me the last column, which is my output column. And in Y, I will take my output column. That is placement. Sorry, that is my placement. Right now, sorry, I mistake. This is my mistake. I gave one more comma. So uh, my data gets divided into input and output. Now I will basically divide my data set into training and testing. 80% for the training and 20% for the testing. Okay. From sklearn dot model selection, import. I will import train test split. Okay. Now, now I will take my all four variables x train, x test, y train, y test is equal to. I will call my train test split. I will give my x and y variable because I have loaded the input columns and output column into x and y. I will give test size is equal to 0.2 and random state is equal to 42. Okay. Now my data gets divided into a train 80% for the training and 20% for the testing because I have given 0.2 as my test size. Now, now I will create my model from sklearn dot svm import svc support vector classifier because I am dealing with classification problem, so that's why I have imported svc. Now suppose I will create an object to call my svc. Now here I have to give kernel. Suppose like this is looking like a complex data. So I'm just giving my kernel as RBF. Here RBF. Here I explained already when we use different kernel. Linear kernels for linear data, polynomial when we will have some curved creatures in my into my graph. Then we will use polynomial kernel and RBF kernel, which we are using for complex and non-linear data. Okay, so and sigmoid for like neural networks. So this is when we use different kernels. Okay, according to our situation. So suppose I am taking RBF as my kernel. Here I'm commenting some kernels for you. Like for linear, you can write linear. Okay, linear. You can write when you will have linear data instead of RBF. You will write linear. And if you want to apply polynomial, then you just give to poly. Okay, and the last one, which is sigmoid. You just need to give sigmoid. Okay. Now, an RBF I'm using. Okay. So these four different kernels are there in SVM, support vector machine algorithm. So yeah, I'm giving RBF. Okay. Now suppose I will fit my training data into my model, right? I will train my model by my training data, X train and Y train, right? Right? It gets fitted. Now suppose I will check my accuracy of my model. X test, comma Y test into 100. So this is very low accuracy I'm getting. It only 83.7. But yeah, you you got an idea how we can use SVM algorithm for classification. So this is how we can use SVM algorithm for classification. And here we how we can use different kernels according to our situations in SVM algorithm for classification problem. Okay. So in the next video we will see how we can use SVM classification SVM algorithm for regression problem. Okay. So that's all in this video. Thank you.